Sveiki Vilnius, Džiaugiuosi tave matydamas. I hope that I didn't offend your mothers or fathers, but I did my best because that's my first time both in Vilnius and on Build Stuff. So, because we will be talking today about the Postgres, so obviously we will see a lot of SQL. So let's start with the question, the main question: why did I come to Vilnius to talk about the Postgres? And of course, we can say that Postgres is great because it's cheap. It's not even cheap, it's for free. So we can use it for free. And free databases are nice because they are free and nice. But that's not the only reason. Because I'm a huge fan of event-driven architecture, and I'm co-maintainer of the Martin library. It allows to use Postgres as a document database and also event store. So we are extensively using one of the great features of Postgres, so JSON-B capabilities. So you can think about Martin as a Mongo, but with strong consistency. That's one of the things that you can do with Postgres. But I'm not gonna be talking about that. I won't be adverting my tools. Because I want to show you how rich Postgres ecosystem is and how you can benefit in your applications and in your products by using Postgres. So I will start with a story, because we will be focusing here on fleet management. Fun fact, luckily Nico didn't find it. That was a nice finding about dinosaurs, but I don't have driving license. So see, what I'll be talking to you, I'm probably not the best expert in this domain. However, I know someone that is an expert, or actually was, because my wife just switched jobs. But for years, she was working in a fleet management companies, and for example, they had like 3,000 of cars. And we will get back to that. So let's start with show you some code. I hope that's visible at the end. So this is a regular table, nothing spectacular. It represents trips, because in the fleet management, the most important thing is to maintain and manage the trips. So because, you know, all of the cars and all of the people that are going using their official cars, they not always going just for a business trip, right? So let's do some calculation, because this table looks extremely simple, and why am I showing to you? So let's say that we have this table, and it represents like driver name, starts, location, end location. But quite often those applications and this domain need to track a specific GPS coordination, because we want to know precisely where it is. Like think about buses, etc. So let's do a quick math. So let's say that our car is going like working from 9 to 5, so 8 hours, 360 days, so 5 days for holidays, not too many, not still. And we are just recording every second one GPS coordinate. Quite often that's even more often. So in 10 years, if we were counting that for a single car, or for 1 year, for 10 cars, we would get 105 millions of GPS coordinates. So if we have a look again on this table, then you always know that if we are normalizing our data, then we are getting this big star of dependencies that is looking like a enterprise ship from the Star Trek, right? So think about these strips as just a central piece of the tables. So if we try to keep those hundreds of millions in the table, then for Postgres, hundreds of millions are not too much. But this is just for 10 cars. So let's imagine that we have 3,000 cars, like my wife was dealing with. So it would be effective if we keep all of the coordinates and if we were trying to join them in the single statement. And here I added one more line, and this is the partition by. And Postgres has the capability to provide the partitioning. And let me try to do some simple drawing. Sorry for my drawing skills, but let's say that this is our trip table. And or GPS coordinates table. And if we have there like those 105 million of records, then that wouldn't be performant, and our storage would take a lot of space. So in Postgres, if you say that you can partition by, then effectively Postgres internally is breaking down our main table. So for example, trips table. I told you that I'm really bad at drawing. Although I like doing that, so that's the same as with programming. So, so if you are saying that you are partitioning Postgres by something, then effectively underneath Postgres is creating or will be using all the different tables. So if we get back to our code, then here I'm saying that I'm partitioning by range. So for example, I can say that trips for the certain month or certain year will end up in the specific table. We have more options like by list, so we can provide a list of values. So for example, extremely useful for multi-tenancy because we can partition by tenant. Or we can also partition by hash. So by hash, we can do some weird calculation of values in our columns. So if we run it, then yeah, that's fine. And unfortunately, Postgres won't automatically create those tables. So see, this is something that you don't see too often, while in SQL. But what effectively it's doing is that we are saying that for this month range, so for this current year, let's create a table for each month. And that's unfortunate because that's not something that you typically would like to do, so setting up upfront all the tables. If we run it, then see, we will get, even in our database IDE, we will see this list of partitions, and they are just regular table. You can either query directly for a specific month, or you might be just querying for the main table. The thing is that you can also even place partition on totally different storage, and also by a single line you can say that detach this partition or attach this partition. So that's super useful for archiving. So let's say we don't care anymore about the trips from the previous year, so we can detach those partitions and call it a day. And yeah, it has exactly precisely the same set of tables, columns. So okay, but let's drop this table. Let's create another again. Our table without the partitioning. And we will be discussing how to make it more automated. Because we developers are lazy, or at least I'm thinking about others as I am lazy, and I don't like to do this stuff by hand because I'm 100% sure that I will forget about it at some day, like renewing certificates, right? So, we will be using some extension, and I will be showing you two extensions today. One is the TimescaleDB, and the other one I will say later. And do not focus on the specific extension, but think what extensions capabilities of Postgres can give you, because Postgres has a lot of possibilities. So by this simple single line, it's a Postgres SQL statement, we can enable some extensions, and we can extend the default Postgres capabilities. So we can do it in multiple ways. We can add new types, we can define new indexing methods, we can storage methods, whatever you can come up, because what's extremely powerful about Postgres, and I think that's the only relational database that has these capabilities, is that this plugin mechanism is the internal part of their engine. And that's one of the things, why is it so powerful? So it's not a second-class citizens, like for example in Oracle, it's like a built-in into the Postgres. So this is the example of the Docker file. So how you need to do, what you need to do to enable this extension. And of course, this may look a bit cryptic, but what I'm doing here is I'm downloading the TimescaleDB package from wget, and I'm installing it because to run some extensions, we need to have also capabilities to run those extensions on server that is running Postgres. And also natively, you can think about those extensions as packages, like NuGet packages and npm packages, because they have capabilities also they need to provide you a way to gradually update and upgrade extension, and also possibility to install, uninstall. And again, the Docker file looked cryptic, but I'm sure that you cannot read it, but it's intentional because I even wasn't possible to list all the extensions that you can have automatically on your cloud provider. So this is a screen from the Azure RDS. So you have a plenty of extensions that you can just enable me on my databases, including TimescaleDB. Same for AWS and similar for Google. So it's not that you need to have a full control on your server and you need to do this Linux magic. You can just tell your cloud provider to enable it and call it a day. An interesting fact is that there is a new initiative, a new tool that is called dbdev. And this dbdev is like a npm package manager for Postgres extensions. So it's an extension that allows you to manage extensions, and then you can just call this one and it will install you automatically. But yeah, going back. So we will now call something that is called create hyper table. It already sounds smart, like hyper extension. And hyper table is not something that is extremely fancy. It's fancy underneath, because this is extension and one of the functions that Timescale is doing. And hyper tables are taking the raw data that we are placing in a regular table, and it's adding all the fancy caching, etc. And after that, it's doing something similar to partitioning. It's not using the built-in partitioning, but something similar, because Timescale was created before the partitions were becoming more powerful. So here, we are doing the same stuff that we would be doing in partitioning, but TimescaleDB is really focused on time series data. So at first, it gets not evaluating any constraint, etc., and then batching the operation and sharding our data, which is quite powerful, as we'll see in a moment. So let's try to insert some data to our regular table, because even if it's underneath the hyper table, then we still can access it with the regular SQL statements. And let's do some fancy report for our manager. So it's like calculating the fuel efficiency, which in our case is just an average of the distance and the fuel liters that we used. But you can think about more intelligent way to calculate this fuel efficiency. I won't be teaching you today SQL because you probably know it better than me, but let's go with the features that we can use. So effectively, if you see this SQL statement, then think about those fancy reports that especially those gauges that our managers love. Yeah, is it good or not? Yes, no, simple decision, right? So yeah, if we run it, then yeah, it's just SQL statement. But if we had just this simple SQL statement, then it wouldn't be performant if we have those millions of records, right? So we can use the materialized view, and we can extend it with the TimescaleDB capabilities. So plugins in Postgres can also extend like views, indexing, and so on and so forth. So materialized view is just creating, like, you can think about it as a read-only table that is refreshed from time to time. And in the regular Postgres materialized view, we need to explicitly say that please refresh me this view, or set up some cron job that will be doing that. It's quite tedious. But as I mentioned, TimescaleDB is focused on the time series, So it would be kind of cool if we were working with the time series data, and if we had this materialized view, then maybe Timescale could refresh it for us, right? So if we are saying, this is saying that Timescale, please manage this materialized view, and we can also do some stuff built in for time series. So for example, time bucketing. Time bucket is also a function that we are getting after installing the TimescaleDB plugin. And time bucketing in general is a simple aggregation. So we are saying that our time bucket is 1 day, then we will get all of the data that we have for the single day, and it will be grouped, right? So we will have like a bucket of days with the aggregations. So if we run it, and if we said that, we can also say that let's do it for like 1 month, so 30 days, then we will create materialized view. And to give capabilities to refresh automatically, so TimescaleDB will handle our refreshing period, then we can call the method addContinuousAggregatePolicy. It's also, again, a fancy name. Seems that TimescaleDB likes fancy names. But effectively, we are just saying that this is the name of the view. Start with the data from last 3 days. This is where you should finish, so like a second ago. And from now on, just refresh me this view every day. Super simple. And that's kind of cool, because I saw that people were doing really weird stuff, like, for example, installing Kubernetes just to run cron to refresh view or run some periodic job, or calling scheduled AWS Lambda just to call some stuff. So I'm not saying that having this cron capabilities inside database is the ultimate choice, but this is something that is kind of cool to have if we have such features that we would like to run continuously on database. Of course, with great powers comes great responsibility, so remember. So yeah, we added this continuous aggregate, and not only we can do it, of course, on the periodic schedule, but we can also say that, yeah, please refresh me at that specific moment. So for example, we can call it when our manager is opening screen, right? And yes, this interval is one of the example of the interesting capabilities, type capabilities. It can parse some string with the time span, human readable time span. And let me show you a quick example how, for example, you can create even your own extension with your own types. So for example, Postgres provides the possibility to define so-called domain types. So by domain, it means that it's specific for the business domain. So in this case, we can say that our email address is a type, and we can add some constraint on that with some really parsing rules. I'm sure that this regex is not correct. I don't know if there is a single person on earth that knows correct for email, but nevertheless, we can also set, while creating this table, that, hey, this is email. And if we try to run inserts for those to this table, then the first one will succeed and the other one will fail, because we have this domain email address violates check constraint. So again, we probably don't want to get back to the days where we had all of our business logic in our database, but knowing that this exists and that we can do such stuff easily is, I think, quite interesting and can be useful. But reports are cool, dashboards are even better. However, no one wants to just continuously refresh the view and check whether, for example, someone did some trick and had extremely low fuel efficiency, which could mean that probably he cheated on us. And it's, I mean, everyone is doing that, unfortunately. Like, for example, my wife was telling me the story that one of the managers had broken their back because of the ski that he tried to put inside his business car. But so yeah, we would like to have those alerts when something is going wrong, right? So we could define some tableful alerts, and we are just saying that this is the fuel efficiency that triggered this alert, and start and end time for this particular time when we observed that someone had some anomaly. And to have that, we will write a function. We won't be going into extreme details, but we have some fancy magical efficiency factor, which is 5. And we have select. So we are taking data. It's a similar select as we had before. So doing the buckets per 1 day, calculating the fuel efficiency from the table from the materialized view, and checking whether the fuel efficiency is below the magic factor. And if it is, then we are inserting the data. If we already have alert for that, then we are just updating it. Maybe someone fix it. And not always everyone tries to cheat. Some people are just lazy as me and forgets to put this information. So maybe someone reminded themselves, or the manager reminded them to put the trip data, and then maybe this fuel efficiency alert should disappear. So we should also delete. And if we have this function, then also TimescaleDB provides us capability to specific job. And we can say that run this job every second. So we are providing the function name and also the interval. And that is not extensively for the timescale, because we have also much lightweight extension like pgcron, which is by default installed on most of the Postgres installations. So you can also specify job just to do some data manipulation, because there is no reason, in my opinion, to just take out the data and move it again just to calculate some basic alert. And if we run it, then we can do some fancy joins and get the fuel efficiency report. So those are our alerts. And again, I don't want you to say that this is, and make this talk TimescaleDB love letter. The reason is just to show you that Postgres, it has a lot of built-in capabilities, but where it shines is when you combine those multiple packages that just can elevate and speed up the things that you normally would need to do in a tedious way. So the other extension is the PostGIS extension, and PostGIS extension provides us capabilities for example, tracking locations and showing the map view, drawing the geometry, etc. And if we add PostGIS, then, for example, we can say and alter our table and extend it with the root column. And root column is the geometry, and this 4326, this is magic factor, but is for those geolocation people. It's like you should just use it. It's a type of geometry that most of maps like Google Maps and etc. are using. So you just type this magic factor, really. So geometry means that it's like a route. So think about the trip in the Google Maps. And once we run it, and if we call it, then, well, we will see that, I hope that you see, there are only nulls because we altered and added empty table. So wouldn't it be nice if we already have those location placed as strings to move it to the root? And actually, we can do it. So we can write update, and PostGIS provides us also some function to parse text into the GPS location. So here I'm just saying that parse me this point that I had in the column, then make me a line from start position to end position, and transform it and make it a route. So it will be a route with a single line. Not perfect, but still it can provide us data for the basic needs. And after that, we can also alter our trips table and set it to not null. And if we now select the data, then we see that our route is prefilled with some blobs that we cannot understand, but it's not a big deal, because if we like, then we can use st as text, and we can get a proper position which is equal to what we had. So if we go further than that, then we can also think that, okay, so if we were able to extract the root and make it a proper column value, then maybe we can do the same for distance, for start location and end location. So drop those columns or calculate them. And actually, that's what Postgres also gives us. And generated always is a vanilla Postgres capability. So you can say that this is the calculated column. It's like a getter in the C#. So we can say that generate me based on the data from other table. So here I'm saying that calculate me the length of the route and put as distance in kilometers. For start location, take the starting point from route, and for end location, just take the end point from the last point from the route. And what's more, we can even say that this should be stored as the regular value. So actually, it's like a calculated column that it's stored. So you can index it, you can get it efficiently without doing in-flight calculation. So after we run it, then if we select, then again, we will have this route, and we will also have the start location, end location. So the reason why I'm showing you is that by combining just, those two simple plugins, and with not a lot SQL, I know that for some people too much, but but this is Postgres talk, sorry. So by that, we can just quite easily build something that is powerful, and we didn't put even a lot of effort into that. And those PostGIS data can be also indexed. And I saw that you can even partition. So for example, you have the data that is in some specific location, like for example, district in your country, and you have different departments in different districts, so you can partition even data by this route. So if we, again, we need to refresh that, we need to select, and after that we have, again, our fuel efficiency is still calculated. So cool, nothing is broken. And what I wanted to show you, this is the current structure of our table. So we have timestamp in, as you see, we have geometry, etc. So that's pretty neat. And let's go to grand finale. And let's get back to the drawing. And I have a question for you. Let me try to draw a few blocks. And let me do a quick check. Besides, this is an ugly image, then what does it look like? What if you look on this drawing, what did you think about it is? It is not a table, but is inside our database. Partition, close, but not yet. Yes, kinda, but it's not table and it's not rows. It's something that is deeper than tables and rows. What is the central piece of our relational databases and in general databases? How they work internally? Yes. Yeah, exactly. So good answer. It's each of our database. So if we have MS SQL, it's called transaction log. In Postgres, it's called WAL. And it's WAL. And it's write ahead log. So for sure you know it, but just to recap, tables from the perspective of the database are just read models. If you are inserting, updating data, then first they are getting into the append-only structure. That is called write-ahead log. So if you have insert, then you have some update. Let me just draw D for delete. Then again, you have update. And databases are just working like an event sourcing. You are just appending new row when you are inserting, updating, deleting data. And then there is a process that once you are committing this transaction, so let's say that those 3 operations were in the transaction, then Postgres or other database is just, after committing, it's just taking all those rows and updating tables. And after that, most of the databases like MS SQL, SQLite, and so on and so forth, after committing transaction, those databases are free to go. Like we are saying, okay, I don't care anymore about those data, about those rows and these entries in the transaction log. You can delete it. They won't immediately do it, but they will do it at some point. And in Postgres, that's also the default behavior. So if you are inserting, updating, etc. data, then it will disappear after committing transaction and after some time. But Postgres has something that is called logical replication. And the difference between the regular replication and logical replication is that regular is just we are pushing the blobs from one place to another, from one Postgres instance to another. And with the logical replication, it's called logical because we are sending information precisely of what has happened. So you will get the information that this was the insert, then you had delete, and then you had update. And you can also specify which tables, which columns from those tables you would like to get. And that's quite interesting, but what you can get with it is if you mark a specific table that is under the Postgres logical replication, then the Postgres won't be removing entries in the write-ahead log. And what we can do about it, we could change Postgres into push notifications database. Or if you are crazy enough, then you could make it a messaging queue. And Postgres even allows you to put a message directly in this write-ahead log without even inserting data into tables. So let's try if that works. Let me just show you firstly my fabulous front-end skills is our fleet management app with the alerts. Luckily, no alerts for now. And if we try to insert new trip, and believe me, this is behind below the magic factor. And if we run this insert statement, it didn't work out. Okay, no big deal. Let's try again. Have you tried to turn it off and on? Let's run it again. Maybe I stop the server. Let's try. Okay, is it working? Maybe, we'll see. Yay! I didn't have the API application enabled. So let me just tell you what just happened. So in wall, we can say that if we have, let's say, 2 tables, like trips, alerts, etc., and we know that those entries are coming from those specific tables, maybe we don't care about this update, then in Postgres, we can have something that is called replication, so the publication. So you can think about publication like a topic in Kafka, queue in Rabbit. So we can say that for this publication, I would like to get all the messages with the information of what has happened in those 2 tables. Cool. And after that, we can define the replication slots. Or actually, this is like a topic, and slots are like a consumers. So you can connect your application directly to your slots. So for example, our fleet management application. And if I think that most of you are coding in C#, so let's have a look how we can do it. So let me find the code, yep. And go here. So if you are using NPG SQL, and if you are using Entity Framework or Martin, then underneath you do. and you can also do it explicitly, then you can have a specific connection that is called the logical replication connection. It has a bit more capabilities, and you can say that start replication for the specific slot name, and you can even say that start from a certain position and connect to the specific publication name. And after that, you will get in the as async enumerable, you will get each message that you inserted, updated, deleted, and much more. Because if you have a look on that, then there are much more messages, but they are still quite okay. Let me find all. Yeah, then we have like delete message, insert, relation message, that table structure has changed, and so on and so forth. So what I did here is that I just forwarded this async enumerable of information from Postgres into the SignalR, just directly. And I connected from the React application, and that's how it goes. So I think that's extremely, extremely powerful. So to wrap up, I just show you a small piece of magic that you can get in Postgres. So for example, you can have the so-called Citus plugin, or in other words, Azure Cosmos DB for Postgres, which is just a managed Citus. And Citus just does the replication distributed Postgres. So it automatically distributes tables between multiple nodes and get the high reliability and high clustering and so on and so forth. Or, for example, Amazon has the Aurora DB, and they just took this whole storage engine from Postgres, but the engine from Postgres, and replaced the storage engine. And they are storing that on Amazon S3, which is like Azure Blob Storage. And by that, they are getting much more guarantees of distribution. It's, again, faster, more reliable. We also have capabilities like NeonDB or Supabase that are making Postgres also be able for the serverless world. So that's quite nice. And Postgres is not only that it's just cheap. Of course, it's, as we agreed, it's for free. You can use it. It's available on all cloud providers. You can install that on premise. And Postgres is just super powerful database. And if we are just using the regular tables, that's fine. But maybe we could have a look on and check how rich Postgres ecosystem can help us to deliver our business application faster, with better quality, maybe with the less overhead, less operational stuff. So thank you a lot. It's Achu. And if you have any questions, you can get me after the talk, or I'll be here the whole conference. As I told you, I'm first time in videos, so I don't have friends yet here, but I'm happy to have more. And if you scan it, then you will be directed to some ransomware, to my blog, where you can just go through a similar narrative as I show you, so you can share with your friends or just recap what you saw. And if you are shy to come to talk with me, then you can also drop me an email. So thank you a lot. It was a pleasure. Ačiū.